Hello everyone, in this video we are going to discuss the neural network and deep learning's concept, how to solve MNIST problem using multi-layer perceptron. Without wasting any time, let's jump into the code. So first of all we need to install particular libraries. In this case we are not using NumPy here in the code, but for the deep learning is the you can say the basic library for data science. So it's better to install it for the further code, but it's not required for that one for sure. And then you can install OpenCV, Pandas, Tensorflow, Matplotlib by using simply pip install command. So let's jump into the code. I am assuming that you have all the necessary libraries and you have already set up the environment for Python. Then let's start from importing the libraries. So first of all we need NumPy. So I'm installing NumPy as np is a, or we can say a simple variable. We will use it as instead of writing NumPy as a whole, we can simply write np. And for pandas, to avoid writing pandas again and again, we can simply write pd. And same goes for all the modules. So we need NumPy, Pandas, TensorFlow, SGF, and we will also going to use the TensorFlow's built-in keras. Though you can use keras library as a separate module by using simply pip install command, but now I'm using TensorFlow's built-in keras. And yeah, so these are the libraries. So first of all I'm going to run this cell. After that let's jump into the keras dataset. So what's MNIST dataset? MNIST dataset is a handwritten digits dataset where there are 10 classes for digits 0 to 9. If you wanna learn more about the MNIST dataset, I have already video on this channel. You can go through that video. That's 2 minutes video. So it explained like what is MNIST and what it is about. Okay, then now we will simply load the dataset by keras datasets dot mnist dot load data. So after loading that, we stored the data into those variables. So we created 2 tuples, one for training data and another for testing data. So in the X train there would be training samples, and Y train there would be training labels, so and so on. So I'm running this cell as well. Now let's check the shape of the X train array. We can say like how many rows and columns it contains. Let's see. So it has 60,000 samples. I have already explained this in the that video. Like the MNIST dataset has 60,000 samples for training. You can simply consider 60,000 handwritten digits images. These images can vary any class, like it could be 0, 1, 2. So in total there are 60,000 training samples, and each image size is 28 by 28. You can say 28 pixel by 28 pixel, 28 height and 28 width. So if we check the shape of testing data, so that's the shape for testing data. As we all know that in deep learning we need more samples to train the data rather than testing data. So if we want to create the complex models, if we want to increase the accuracy, so we need as much samples as we can manage. Of course, to run more samples, of course to train on multiple samples, we need processor and systems configuration. So it's varies on data. So the MNIST data, for MNIST it's quite simple because the image resolution is not that much, it's just 28. So we can simply load it and process it in a simple laptop. You can say we don't need a high configuration laptop over here or computer. Okay, so let's back to the code again. Okay, so now let's check how many as training data contain the images. You can say the images are stored in the in array format. uh, the array digits like from 0 to 255 values, and in the y there are labels of that data. For example, let's say x contain the data. Okay, let's check any data sample over here. I'm adding a cell. Let's check the x test. So x test is an array. It contains values zeros and ones according to the pixel range, according to the grayscale of the image. Alright, so y contain the labels like whether the stored array is image of 0, image of 1, and so on. So let's check y printing that image. So I am printing image white. Let's see what data is here on label 0, on 0 index of y train array. So you can see, okay, let's run that code for first. So label is 5. So if you wanna see the visualization of that array, you can simply use matplotlib's im show image show function. It will show you the image. So as you can see, it's a handwritten digit and the value it's 5, and y x stored the image itself and y stores its label like it's 5. So then now we are going to train an algorithm that will going to input, like for example, 60,000 images on in that algorithm, and we will train that algorithm in a way that like a children we are going to teach like that is 5, you have to remember that is 5, that is 6. So let's say we are going to put 10,000 images of 5, 5,000 images of 6, and then we are going to make that algorithm learn, okay, that's 5 and that's 6. So in future if we are going to provide the image of 5, it should recognize it. Okay, let's go to further. So for any deep learning or data science task, we need to process the data first. We need to transform data in the particular format so that it's acceptable in the for the algorithm. So let's see the values. X trains maximum value, as I mentioned earlier. Training data contains the values ranging from 0 to 255 pixel value. So you can see the maximum value for X train is 255 and minimum value is 0. Same for the testing data. And let's see the values for Y train. So you can see the Y train array contains the values. Let's check first 6 values. Yeah, it's a 5 0 4 1 9. So it could be any value between 0 to 9. The training data range from 0 5 5. Let's rescale it. The rescaling is an essential process in any deep learning task. What here we are going to do here, instead of using 0 to 5 5 to make it computationally simple, we are going to convert those values range to make it range between 0 and 1s. So simply there are various algorithms and method used for this as well. We can simply convert this value by dividing it to the maximum value. Here in this case 255 is maximum value, so we can simply divide our data, extrain data to 255. Same for the testing data, and we have stored that value into new variables called xtrain processed and xtest processed. So now let's check what is the minimum and maximum value. So by it's like by simple math we can simply judge it. Like if we divide 255 by 255, then 1 would be the maximum value. Let's check it whether it's the same. Yeah, so 1 is the maximum value, again 0 is the minimum value. If we divide 0 to any number, it would not make any difference. So yeah, so that's why 0 is minimum and 1 is maximum value. The pattern would remain same though, like we have divided whole array into 255. So the pattern between that data would remain same, but the values would be lesser. All right, so let's make the classify. It's the, I can say it's the most simple perceptron, or we can say neural network I have created. So it as we know, like a neural network contain input layer, output layer, and there could be n layers, number of hidden layers. So okay, first of all I'll import sequential model from keras, and then we have imported layers: convert 2D, max pooling, flatten, dense, dropout, optimizer, etc. So I'll not going to that further. If you want me to make separate video on the concept of like the deep understanding of what is sequential model, what is convolution 2D, what it do step by step, what is pooling, so you can write the comments. I'll make a separate video for all of these concepts. All right, so that's the very simple model I have created. So it's the sequential model, and the first layer is flattened layer. Let's google any of the neural network for you to make understanding. Let's search deep neural network with one hidden layer. Yeah, so as you can see in the image, let's take that one. Okay, that image. Yeah, so that's input layer and that's output layer, and these two are hidden layers. Similarly, you can consider the first one, the flattened layer, as input layer. As our image input size is 28 by 28, it gonna convert that automatically. It gonna multiply it and it will convert it into 784 or something. Yeah, so in on the first input layer there would be 784 neurons. So these are called neurons. So here are 3 neurons, but in our perceptron there would be uh, 784 neurons for first input layer. And then there is dense layer. You can add any number of neurons to the network. So it the output accuracy all depends on the number of hidden layers and the neurons you are adding into the network. So that is the first hidden layer. It contains 128 neurons. So that one is a fully connected neural network. You can say each neuron in the network is connected to the each and every neuron in the next layer. So all of the 784 neurons in the first layer are connected to the 128 neurons to the next hidden layer. And we used activation function called ReLU, rectified unit. So yeah, it's something called that ReLU function. Most of the time we simply say it ReLU. So ReLU activation function is used on the neural network. It is used to avoid like linearity. The ReLU network, we use ReLU networks to on data where there is complex data. So it's very efficient on the complex data as well. So for the most of the image processing task we can use ReLU function on the hidden layers. And then its activation function, there is the formula. There is sigmoid as well. Most of the time we use sigmoid when there are just two classes. So I can make a separate video. I will not going into the details of the every activation function, so let's skip that part for now. And the next layer is dropout layer. You can consider that layer as a dropout layer. I have added that layer for regularization. Now what is regularization? It You can simply say we add a small error to avoid overfitting problem. So let's take an example. I am opening a paint. For example, what overfitting is called? When a neural network learn on every when the neural network is dependent upon the input data, extra dependent on the input data. Let's keep it simple. For example, you have trained your neural network on like on ones of like this, or yeah, one. If in the test data, for example in the input data there are all most of one's image like this. If the your model is overfitted, what it is going to do, if there is one that is a bit like that, it is not going to recognize it because it has overfitted, it has overtrained on the over is over dependent on the training data, so it is not going to recognize that one. So to avoid the overfitting problem, we have used the dropout here. Dropout 0 0.2 means we have as I mentioned, that is fully connected neural network. Each neuron in first layer is connected to the next layer. By using dropout, we have disabled some links, we have deactivated some links, we disabled 20% of the links to avoid the overfitting problems. And then finally, that's the output layer. The output layer contain the number of neurons same as your output classes. In simple words, in the MNIST dataset there are 10 different classes for each digit 0 to 9. So that's why there are 10 neurons on the uh, output layer. Most of the time we use softmax function for the output layer. Now I am running that neural network. Let's see the summary of the network. So you can see flatten, yeah, so flatten layer has input shape, it's 784 means 28 by 28. So there are 784 neurons on the first layer, and on the dense layer there are 128. So we did some dropout, we disabled some links, so there are same number of neurons as the previous layer, so there are 128. And on the dense layer there are 10, you can say um, sorry, yeah, 10 neurons. Okay, so these are the trainable parameter. How we calculate that value? It's we multiply 784 into 128 plus 128. So let me calculate it for you. We can simply use Python though. Alright, so 784 into 128 is that, and then if we add 128 to it, yeah, then that's the same as that value. So that are total number of trainable parameters. So as I mentioned earlier, I can make a detailed video on the theoretical part, how these parameters are calculated in detail. So yeah, and that one is same. You can also see there are 1290, 128 into 10 plus 10 would be that number. So altogether they are total number of parameter, that one. So next step is we have defined the structure of our multi-layer perceptron. Now it's time to compile that model. To compile it, we have used the Adam optimizer, and that is our loss function. That's how we calculate the loss of the function, and the matrix is accuracy. So we are going to evaluate that model by using accuracy score. So yeah, that's compiled, and the train and test model. So all right, we use method to train the model. So I have provided the training data, x train and y train, and these are epochs, so number of steps it is going to take to train that model, like how many times it is going to repeat those steps. So for this example, let's make it simple. I did it 5. So the optimized number of step is completely depend upon the data set and the complexity of the model. So the MNIST data set is not that complex, so 5 epochs would be great to achieve the maximum accuracy. Let's see the output. So that's running the epochs, so it may take a bit time. So you can see the loss of after every epoch. So you can see the loss after every step, you can say the loss is decreasing and the accuracy is increasing. So loss is, you can simply consider it as an error. After every step it's decreasing in previously it was 0.4, now it's 0.3, and the accuracy is increasing. Accuracy already it's just first epoch and the accuracy is 0.91. It may increase and or decrease after every epoch. Again, it depends upon the process of that neural network, that I can make a separate video for that one. Alright, so now after the second epoch, the accuracy score is 0.95 and loss is decreasing. So you can simply consider the at the moment the training the model is learning, like okay, that's the pattern between the data, that's the array. For example, you have passed 60 it's processing 60,000 images, 60,000 training samples, and then it will make decision according to that data. So after that finish, let's yes, the process is going on. Let's discuss the evaluation part. So you can we already checked the loss and accuracy score for each epoch. So after that you can evaluate it. You can simply use model.evaluate function to check the final scores, final testing score. Okay, so we trained the model on the training data, and that is the loss and the accuracies according to the training sample, or the samples on which you are training. The testing sample are completely different, like you teach your model on 60,000 samples, and now to test that model whether that model is going to fit for the future data or not, there are 10,000 testing sample. We can check the working or the efficiency of our model for the testing sample. So these samples are completely unknown to the that model. So let's check whether it will going to work on those sample or not. How for the training sample, the accuracy is now 97% and the loss is 0.07. Okay, so let's check the model's efficiency, or you can say model's performance on the testing sample. So yeah, it's calculating for each 10,000 samples. Now it's performing good on testing sample as well. The output is even more, like it's 90, it's approximately accuracy is 98%, and loss it is telling the overall accuracy according by considering all the samples. Of course, on the compared to 60,000 and 10,000 sample, the mean value for this might be less, so that's why its accuracy score is a bit less on the training sample, because there are 60,000 sample and on the testing there are just 10,000 sample. That's why it's 979. All right, so now training loss, we can plot that data. So that's the simple. I have stored the data on the history. When we was training the model, I have created a variable named history, and now we can plot the data on using a matplotlib line graph to check the graph loss and accuracy. So yeah, all right, so I've used plts because I'm using subplots over here for the that is that is for the first column and that is for the second column of the subplot. So on the left side there would be loss, and on the right side there would be accuracy. Yeah, so you can see with the each epoch the loss has been decreasing and the accuracy has been increasing after every epoch. Okay, now let's check the bunch of samples. Let's take the bunch of samples and now check and visualize the model's performance. So we use model.predict function to make predictions. Okay, so okay, x test. processed contain our testing sample, and let's see what's on the first index. All right, so now I will discuss why that argmax is used. According to the prediction, that one is 7, and let's check what's on the y test. What's the level? Is it actually 7 or not? Yeah, it's 7. So the prediction is completely correct. So okay, now let's understand what is the argmax called. So as I let's take that one as example. There are 10 neuron on our multi-layer perceptron. So it, after the output layer will uh, return the probabilities. You can simply say, if I can, for example, after every neuron, let's say these are 10 neurons over here. So after each output node, you can say there would be probability. For example, this neural network thing, okay, that is for 1, that is for 2, that is for 3, and so on. So there are 10 different neurons, so it would return the probabilities of each class. For example, let's take for example, the provided image is for 2. Now it will return probabilities like that. It's 1's probability is 0.1, 2's probability is 0. Let's say 8, 3's probability is 0.1. So the output node, each neuron will return the probability, like how likely it think that the provide number is that class. For example, for the if we passed 2 in that neural network, it think that there is 0.1 probability that it's 1, there is 0.8 probability that that's 2, there is 0.1 probability that it's image of 3. All right, so argmax function will return the index of the maximum number. Okay, let's open that notebook again. I'll show you the working of argmax function. Let's take that array 10, 20, 300, 4, 5, 6, 7. All right, dot argmax. It's okay. List has no attribute called argmax. It should be Python. List has nothing, no method for a method called argmax. So let's convert it into numpy array. Okay, numpy array has that method. Oops, sorry for that. It's not appy, it's array. Yeah, you can see it has returned the 2 index. 2 index means 3000. So there is 3000 is on second index, that's why it returned the index 2. For example, I made it that value. Now it is going to return the 0 index. All right, so same goes for that as well. As I mentioned, each node return the probability of each class, so it's on in the order, it's in the ascending order, that's why it return the class. For example, there is a first index return the 0 probability, first node return the 0's probability, second 1 probability, 2 uh, then next node return 2. It's in order wise, so that's why it is going to return the exact index as class label. So all right, so let's check. I have made predictions on X test data, and then uh, there are that figure.fig size is used to control the size of graphs. Now for this I am going to just show 9 images, so that's why I added a for loop. That part is completely optional. You can simply, it's just for validation whether model is working successfully or not. You can simply make predictions like that. Let's say let's check the output for second. So a model says that on the 2 index it's 1. Okay, let's say whether it is 1 or not. Actually, plt dot, you can either check by plotting image, or you can check the value of y test for the same index. Plt dot im, so x test of 2. Yep, you can see it's 1. And if you see y test of 2, it will store the label 1 as well. So yeah, our model is working as expectedly. To show the data in bulk, I'll show the 9 different labels over here, 9 different images and their prediction. Yeah, so these are the images and that's prediction. The prediction is completely accurate according to the model. So for 7 image it says 7, for 2 it says 2, and you can check according to the, yeah, it's a 9. Let's say we want to check the images for first 15 images. Oops, subplot is, I just plotted 9 images over here though. Alright, let's wait for, yeah, so it's an issue now. Say 16. So I will utilize the 16 plots over here. The images would be too short though. Yeah. Alright, let's remove that prediction word from here. You can change the output visuals according to you. You can make the number of rows and columns according to your, yeah. Let's, for each class, for each test label, it is returning the accurate value. So yeah, that's all about how we can create a simple neural network in deep learning to show MNIST dataset.